choose Onshape is because, first of all, it's cloud-based. So, for example, if you're doing your work and your battery suddenly dies, everything will be saved and you don't have to start over again. And another reason why we choose to use Onshape is that version control and collaborating is really easy. You can think of it kind of like Google Drive, where everyone can collaborate all at once. It's also online, so you can just access it via any sort of web browser that you have. Another cool thing about Onshape that we'll get into later is that there's a feature called feature scripts, and it's basically where a lot of people have made tools for you already, and so you can just use those tools, and it makes CADing, especially for a robot, a lot simpler. And finally, Onshape is owned by PTC, which is a sponsor for the program.
So now let's talk about how to get started with Onshape. So the first thing you'll want to do is get an Onshape education license. So this is available for all students K to 12. So the way you do this is that you go to onshape.com/en/.
Also, they need to get Onshape. We already had a head start. So.
Is someone talking?
You can continue.
And then you'll fill out your information. You can see from the screenshot, to get started, you fill out your first, last name, email, student, and school level. The benefits of an Onshape education license over a free license is that you can make private documents while still being free. With a free license in Onshape, you can only make public documents so anyone can look at your CAD, and private documents are private, so yeah. The next thing you'll want to do is get access to the FTC parts library. So this is something maintained, this is an official parts library for Onshape in FTC. So the way you do that is that you email first@ptc.com to gain access to the library. And then after that, they should just share the library with you.
Okay, so now we can move into getting started with basic parts of Onshape. And there's a lot of things in Onshape, and it may be a little bit tough to do at first, but we'll just go through some basics so you can make a basic shape or element in Onshape. So the first thing that you will want to do is to create a new document. And this, as I mentioned before, is very similar to Google Drive. So there's a little blue button in the top left-hand corner, and you can basically just click on it and a little drop-down menu will pop out underneath, and you can select the line that says document. And once you click that, it creates a new Onshape document for you to begin CADing.
Oh yeah, by the way, the URL is cad.onshape.com to access this. So
you can, once you click the new document button, it'll ask you to enter a name. And so we're just doing a demo. So it'll just be a demo, and if you click enter or okay,
So Part Studio.
All right, so the first thing that we want to go over is a Part Studio. So right now, Andrew has opened a Part Studio on his screen. And so a Part Studio is one of the most basic parts of Onshape. So there's essentially two parts, a Part Studio and an assembly, and you make all of your parts in a Part Studio. And so this is what it looks like. There's a lot of different ways you can look at it. Right now, there's 3 default planes. And you can move around to sort of pan around, but since we have nothing here, we'll just get started by making something. So the first thing that we're going to show you guys how to make is a sketch. So a sketch is really just a 2D drawing. That's the best way to think of it. To make a sketch, you first want to select what plane your sketch is on. So right now we'll make a sketch using the front plane, but you can use any. You can also make your own planes other than the ones that are given here by default. And so by clicking on that button, you're facing the plane directly, and that makes sketching a lot easier. So there's a lot of pre-made different tools that Onshape has for you. So first we're making a circle here. We're using that circle tool, and you can make lines. And if you're making a completely horizontal line, Onshape will help you and make it horizontal, just so things are cleaner and easier. And each circle has a center. So now we're putting some lines, and these lines are dotted because they're called construction lines. So construction lines don't appear as solid, and so they're a little bit different from solid lines. So right now we have a triangle, and other than just putting lines down, we can make very specific things, specific measurements. So right now Andrew's making a 90-degree angle on this circle, and you can also do other different dimensions such as the diameter. So right now he's set the diameter of the circle to 4.5 inches.
Sorry, there we go.
Yeah, so once you've finished with your sketch, you can just click the green arrow button, or sorry, check mark button, and your sketch is done. And so now that we've made something in the 2D plane, we can elevate our experience by making it 3D. And that's also super simple. You can simply click on the extrude button, which is to the right of the sketch button. And once you have an extrude, right now we'll be making a new part. So we'll be on the new tab, and we want to figure out what we want to turn 3D. And so in this case, we'll be turning the part that we just made, the little circle, into a 3D component. And so right now, see, as you can see, Andrew, as soon as he clicked on that face, it extruded it to, by default, a depth of 1 inch. But you can change this to any measurement you like, either by dragging the arrow on the in the center, or you can type it in. So right now he's typing in 3.5 inches. And that's really easy if you want to make a very specific measurement.
Now next is the revolve, I think. Okay, so next we're going to, another thing that you can do with sketches other than extrude is revolving them. So if you can click on revolve, which is right to the right of extrude, then you will get this menu. So first we select the faces and sketch reasons to revolve. So it can be this one. And then we choose the axis with which to revolve it on. So we can revolve it around this axis. And you can see that we now created this weird shape. So you can do a full one, or you can do just a certain number of degrees like this. So you can make shapes like this, where you take a face of the sketch and instead of extruding it, you revolve it around a circle, in a circle around this axis. So now that we have this part, we can insert it into an assembly. So this is not a very useful part, but for demonstration purposes, we can use it. So once we're in an assembly, we can insert our parts. So the insert button is right here. And you can see that the part that we just made, it pops up right over here. So if you click on this part, it will insert it into the document, and it will position it wherever our mouse is. So, but one part is not exactly useful. So the way we can do it is that we can actually insert multiple parts. So this time, instead of inserting a part from the part studio, we're going to insert a part from the FTC part library. So you can see that in other documents, there is this tab over here for FTC robotics parts users. And if we click on it, we go to this menu. So let's say that we want a Andy Mark part. So FTC game related items, Great Frenzy game sets. So yeah, we can have this rubber duck right in our documents here. And we can insert it like that. So now that we can have these two parts, we can also join them together using a mate. So as you can see on the top, there are a lot of different kinds of mates, but the one you'll be using most often is the fasten mates right here. So the fasten mate just basically takes two parts and it takes mate connectors from them. So for example, we can see on the bottom of the ducky, it automatically detects these mate connectors. We'll just put one right in the bottom of it. And let's say another one over here. And you can see that right now, these two parts, the ducky is going into the part. and we can flip the direction of it by pressing this button. And then we can also turn it around 90 degrees with this button. So now that we're satisfied with this, we can press the check mark. And now you can see that these two are actually fastened together. So for example, if I took this part and I moved it around, the ducky also moves with it. So yeah, that was it, I think. No, we missed something. All right, let's go back to here. Right, we forgot about the feature scripts. Whoops. So here you can see that on the very right here, we have the feature script menu. And here are a lot of feature scripts that I have downloaded, or not downloaded, but saved. So let's say that we want to make a spur gear. So as you can see, now a custom menu pops up. So we can input the number of teeth, the pitch circle diameter, or the module. So let's say that we want this to be 32 diametrical pitch and have 32 teeth. Now we can also adjust the thickness here. Let's say we want it to be 1/4 of an inch thick. And now we have a gear. So this is a pretty complicated part to make on your own, but thanks to the feature script, it was really easy. So yeah, that is our quick overview of Onshape. So for more things, we actually have a few resources here. So here are some feature scripts and configurable parts. So these are 2 documents with feature scripts, which I will now post in chat. So this is the first one. Here's the second one. And then down here we have tutorials. So the first one is Onshape's own tutorial series on the fundamentals. And then the second one is a YouTube playlist for FRC design and modeling using Onshape. So even though it's an FRC tutorial, there are still some videos in there that are pretty useful for FTC as well. So in the playlist, you might want to jump around a bit and only look at the stuff that's relevant to FTC. Well, that's pretty much it on our side. Does anyone have any questions?
Go to the next slide.
Sure. Yes.
So if you guys have, oh yeah, go ahead.
What do you use this 3D modeling for? Do you 3D print your own parts for FTC, or do you use it for something else?
We do 3D print our own parts, and we also do a lot of other stuff. So yeah, we can show a bit of what we were doing here. So this was something that we were doing over the summer here. Our drivetrain. Let us just move over here. So you can see that this is a full complete drivetrain in CAD. So we CADed all of this. And some components of this we will 3D print. Some components of this we will actually cut on a CNC. And some components of this we will actually just buy. So that's what the FTC part library is useful for, because it has a lot of parts that from various vendors like AndyMark or GoBuilda or Rev. And using the parts library, you can just insert them into your assemblies very easily. So this allows us to easily work with a lot of different types of parts. So for example, a lot of this, like these are all from the part library. You can see this big plate is going to be a CNC part. And for example, there's less 3D printed stuff on this because it's a drivetrain and it needs to be kind of durable. But for example, this stuff, this plate we might 3D print for odometry. So yeah, there's You can basically use Onshape or CAD in general to design your whole robot. It doesn't just have to be parts that you 3D print, although you can do it that way. Yeah.
Hey, Gary or Andrew, sorry, there was no palm, so I'm just going to ask. Hopefully, I'm not taking anyone else's turn. Actually, I was going to ask, we are a rookie team and was wondering if the team can actually use Onshape to design the entire robot, or will that be an overkill, given the learning curve to learn Onshape and then actually also design and build a robot? What would be your suggestion?
Well, I think it really depends.
I think it's a good idea to have everyone practice. Like it might be a little late to do it now, but if you are a rookie team and it's not, the season hasn't started yet, I think then is a good time to get familiar with Onshape CAD. And so when the season starts, if you're familiar, you're like at a beginner level or like you have experience using CAD already, I think it would be a good idea to allocate a couple of weeks worth of time to get as much CAD done as possible. And if you don't finish the CAD by your set time deadline, you can move into just building everything already. But if you're starting off with zero experience, I don't think it would be a great idea to start CADing an entire robot at this point in time in the season.
Yeah, you can always do what they call a free build. So instead of designing your whole robot out, you can just try buying parts and assembling it together physically. And then maybe if you have specific parts you want to 3D print or CNC, then you can CAD them, which is going to be a bit easier to do because you don't have to do everything virtually. So I think that would probably be our suggestion to you.
Right.
Got it. So thank you. So as a follow-up, are there pre-built parts that we can repurpose and assemble them using Onshape to build our robot, or do we have to build individual parts before we can start assembling them into a robot?
Yeah, there's a lot of parts that you can utilize. A lot of it comes from the FTC part library. So if we look in here, there's actually a lot of parts from a lot of different vendors. So for example, we can go into Go Builda and then motion wheels. And you can see that they already have a lot of different wheels here. So this whole mechanism wheel, you can kind of just import into here. Wow.
Most parts, if you're viewing them like this part or a product on a website, there should even be like a download CAD button where you can just download the step file to any pre-made parts. So there usually isn't any worry if you aren't super familiar with CAD. You can just download parts, import them into your document, and then just make them together, and you're basically, that's it for your CAD.
Yeah, and if you're starting out, Go Builda makes chassis kits. And if you look inside, they actually have like a full CAD of their entire drivetrain just on their website. So you can download that and import it into Onshape as well.
Great. Thank you so much. Really helpful.
Okay, anyone else have questions?
I had another question.
Sure.
So are there any restrictions about how the robot has to be built, other than it has to be smaller than the I don't remember the exact size, but that size?
Yeah, there are some restrictions on parts. Most generally, your parts should not be able to damage other robots, the playing field, or other people. So, for example, there should be no liquid in your robots, no sharp edges, and stuff like that. And also, there's a rule for buying parts. The rule is that you can buy parts from basically anywhere, but there is this 1 degree of freedom rule. So the parts that you buy, they should only have 1 degree of freedom. So for example, like if you're buying a wheel or something, then that's only meant to roll in one direction. So that's 1 degree of freedom. But then you cannot buy like, I think the example they give is like a claw kit, like because you cannot just buy the whole kit and put it on your robot. You're supposed to like design the claw yourself. So a lot of the details on building rules are in game manual part 1. And so for any questions about the building rules, you should
in chat. It says, does it make sense to model our robot first so that we don't have to cut our robot parts before making sure it will fit? And our answer to that is yes. That is one of the big purposes or big reasons why we choose to use CAD, because if we can model it out in CAD first and it makes sense on a computer, then when we actually build it in real life, it'll make the process a lot simpler, and we won't really run into problems where we find that something won't fit unless something wasn't machined correctly. And in that case, that would be different from the CAD. So yeah, our answer is yes, it does make sense.
More questions?
Yeah.
So who wants to?
Just anyone can unmute and
Yeah,
speak.
someone just unmute and ask.
Oh, hey, I've got a quick question. So I'm kind of curious, how many build members do you have in your team, and how many of them actually actively use CAD to design different parts of the robot? So that's first question. The second question is, if you think about the chassis and the attachments for your team, have you ever built and stuck to the model for the entire chassis or for any of the attachments?
Yeah, so how many members are on our build team? I would say, how many?
6 or 7.
Yeah, we would probably 7 people on our team build. And of those 7 people, maybe 2 use CAD very often. So we've been trying to get more people to use CAD, but it is kind of hard, and it is actually doable for 1 or 2 people to CAD an entire robot, though that will obviously take a lot of time. In terms of your second question, have we ever CADed something and stuck to it mostly? Yeah. So for all of our drivetrains, pretty much the difference between the CAD and the real built drivetrain is very insignificant. And because drivetrains are relatively simple, drivetrains are usually not very game specific. So like if you have a drivetrain and it works, then you don't really need to change it. But for other things like your intakes, your transfers and other stuff, after you CAD it, you may need to make modifications to it in order for it to work with the real game elements. That is sort of part of the natural process of designing something. So for some of our components, we actually, once we make it in real life and we realize it doesn't work, we actually go back to CAD and make some changes. And then based on the new CAD, we rebuild it and then test if it works or not. Or conversely, you can make it and then modify it. And then afterwards, after you modified it, in real life, you can then go back to your CAD and remodify it in CAD as well.
I had one question. Like, can you show us how you can like import the Rev Robotics and Modern Robotics parts into the CAD again?
Sure. Okay, so the first thing you need to do is be on an assembly, and you also need to be part of the FTC parts library group. So you see in the insert menu, we're on current document now, and you'll want to select other documents. And if you're
in the group, because I'm not seeing what, like I'm on the Onshape CAD, but I don't see what you're doing right now.
Yeah, I think you might need to join the group. So let's refer back to our slides. You need to email first at ptc.com in order to access the parts library.
If you want to import parts like immediately and it's very urgent, or you're not in the group, you can navigate directly to Rev's website in order to find the part that you're using, and then download the step file, and then you can click the import button in Onshape to import the part.
Yeah,
into
so
your
we might just demonstrate that right now. So let's just import. What part do we want to import? Let's import one of the channels, maybe. Sure. So you can see that this is the product page on the Rev website. And here there is the CAD. So you can just click on this and it'll download it. Let's go back to the demo document. So here on the plus, you can click import here. Select the thing you downloaded, and then it will import it into Onshape like that.
Okay, I got how to do that. And just to confirm, like every like CAD like part on the Rev Robotics or Modern Robotics is free, right? We don't have to like pay for like the CAD like parts.
No, you don't. They're all free to download. You don't have to pay for them. They're just directly on the website. Okay, sorry, my video feed got messed up. There we go. Okay, so more questions?
Sorry, before we continue, I will drop in the chat a PDF of the slides that we used today, so you guys can refer to them later on. And if you have any questions, you can also reach out to us via email, or you can DM us on Instagram. But right now, I'll put the slides in the chat for you guys.
So yeah, here you can see the whole imported part.
Could you show the belt feature in Onshape? Like, I think that was in that widgets tool, or I forgot the name of it.
Okay, so this is the belt feature script. I don't think I actually use the belt feature script. What I use is actually a configurable part. So if we see insert, hold on, I might also want to link to the configurable part here. Let me find the link first of all. Sorry. Okay, so let me put this in the chat as well. So this is what's called a configurable part. It's slightly different from a feature script in that you don't do it in the part studio, you actually do it in the assembly. So let me just copy this here. So for example, if we go back to this document and we insert a part here from recently opened. So we can click on this and you'll see that it has this whole thing here. Wow, that's a lot of stuff. But anyways, so you can see that these are all things that you can configure with this. And then we can click on this and we can, oh, wow, it's taking time. So you can create a belt like that. And then once it's here, we can still change its configuration. So let's say that we want it to be like 50 center to center, have, and then once we click generate, it will regenerate the belt. Okay, well, sorry for that. But you can see that you kind of have to know what kind of belt you want before, because yeah, that's way too many teeth. So the way that you'll do this is that you'll look up like your center to center distance and like the number of teeth on your belts. So for example, on GoBuilda here, they have a belt calculator. Let's just use it right now. So center to center, 60 millimeters. So 40 teeth, wrong document. So let's say that, okay, pulley 1 teeth, 16 pulley 2. Okay, so center to center distance, let's make that 60 millimeters. And then let's have 40 teeth. And then if we put in all of the right dimensions, then it will make the right belt. So now we have a belt that should work between two 16 tooth pulleys, just like that. So that's how configurable parts work. So the downside to configurable parts is that because they're in assemblies and not part studios, you actually cannot modify them. But that's not as much as a problem for things like belts, because they have all of these things that you can, they have a lot of variables that you can change to modify it. And also it's a belt, so you'll probably not want to do that much more to modify it anyways. So that's sort of how you do belts. Is Onshape the only CAD software we can use, or can we use other CAD software such as Blender? So I personally would not recommend Blender for FTC because it's more for modeling things like STLs versus something like this where it's more parametric, I guess. So there are other CAD software, just off the top of my head, there's Autodesk Fusion 360, Autodesk Inventor, PTC Creo, SolidWorks. So any of these you can use for CAD, and some of these also have education licenses. Like Autodesk has education licenses for Inventor and Fusion 360. And so you're free to use those as well. The main reason why we use Onshape is for the reasons that we listed before, but you're free to use other CAD as well. You're not required to use a CAD software. Any other questions? Is there any way to sync Fusion 360 assemblies and Onshape assemblies? I don't really have experience with this, but probably not. How to join parts together for building a robot. Okay. So, okay, first question, probably, yeah, there's probably not a way to sync Fusion 360 assemblies and Onshape assemblies, unfortunately, because they use different file models. Like from Fusion 360 to Onshape, you have to export it and import it as a step file because that's sort of the universal file for these. And from my experience, the assembly constraints don't go over. So for example, how to join parts together for building a robot. So let's just make a new assembly here. So let's say that, what's something easy? Okay, let's say that you want to make maybe like a drivetrain. So first we're going to make the wheel for the drivetrain. Let's just take a terrain wheel. Actually not a terrain wheel. Sorry. I have not done this in some time. Rhino wheels. Sure. Okay, so let's say that we take this Rhino wheel here. That then next, in order to then we'll want to mount this wheel to an axle, and we mount it to an axle using a hub. So then we'll also import a hub from GoBuilder. So we'll just do it with a hyper hub. And let's say that we want 8mm Rex bore. So then we'll just import this as well, or not import, insert, sorry. And then we can join these together using a fasten mate, because obviously we want this, when you're building this, you'll want this to be fastened. So next we'll do these together. So let's say that we want this part to go into this hole here. So then the way we'd do this is that we click on this edge here. So then that's one mate connector. And then the other mate connector here is like the center of the wheel. So we'll click this one here. And okay, you can see that when you'd make it in real life, you'd probably put a screw into each of these holes. But in Onshape, we actually just fasten the center holes of the two because it's easier to do it that way. Next, what you'll want to do is get an axle. So we can also import an axle from GoBuilder. So I think that might also be in motion. It's here. So let's just get this one. Actually, that's kind of short. There we go. Let's just delete the first one. And then you'll want to also fasten this to your thing. So how am I getting these parts without downloading them from the website? Is that I'm using the part library that I talked about. So if you see, when I'm inserting, I'm not inserting from my document. I'm not importing it either. I'm just getting it from this group called FTC Robotics Parts Users. So that's the FTC parts library, which we covered. So so from FTC. I'll just put this. I'll just put this in chat for convenience sake, but this is how I'm doing this. So yeah, it's very convenient because I can get all of these parts without having to import them. So that's another benefit to using Onshape, I guess. So yeah, you just build a robot sort of in this fashion. So let me actually change this fasten mate right now. So like, let's say that we actually want this to stick out to the edge of this wheel. So then one way we can do it is by using the measuring tool. So we can see that the distance from this face of the axle to the outer face of the wheel is 0.591. So we can just copy that number. And then in our thing, we can offset it in the Z direction by that same amount. And then you can see that now it's like sticks out that much. So, and then you might want to add a bearing and using a Revolut Mate and other stuff like that. But that's roughly how you'd assemble stuff. And also, once you're done with one wheel assembly, then you can put those wheel assemblies into another assembly for your full drivetrain in order to make it easier. Okay, so please in the future just don't post vague questions like that. Okay, so anyone else have other questions? Otherwise, I'll just continue working on this, I guess. Just like wrap up the slide. Are we done? What? Are we done with the slides? Are we done with the slides? I would think so. Okay. So if no one else has questions, then I guess we can end this early. Sure. Okay. Sorry guys, my computer died earlier. But for today's meeting, that was pretty much all the basic information. Where did my mouse go? That we wanted. It's up there. Oh my god. Yeah. Okay, there we go. It's fast. So going back to the slides, just one final thing we wanted to talk to everyone about is that if you can't think of any questions right now, we have lots of areas for you to reach out to us from. For example, you can email us at paragonftc11311@gmail.com, or you can DM us on Instagram, as I mentioned before. We'll try to get back to you as soon as possible. And we wanted to thank everyone for being able to come to our presentation today. We hope that you learned a lot. And yeah, of course, we can drop the email in chat. I think that the differences between Onshape and Fusion 360, I actually don't have much experience with Fusion 360, but one of the benefits of Fusion 360 is that it's not just a CAD. Onshape is maybe a pure CAD. Fusion 360 also has tools for like simulating stress, and they also have a CAM tool, which is computer aided manufacturing. So you can generate a CNC path for it right in Fusion. You can also render stuff in Fusion in the cloud. So that's another good thing about Fusion. But I would say, but I still use Onshape. And the reason why is because Onshape is web-based in a way that Fusion is not. For Fusion, you'll still have to download like a client in order for it to work and stuff like that. Versus Onshape, I can just open it up anytime in Chrome or from wherever. As long as I have the login, then I can use Onshape. Right. And Onshape is probably actually better for collaboration because it works a lot more similar to Google Docs than something like Fusion. So like, for example, in Onshape, we have this shared parts library that I can just access from at any time. And you can have multiple people working on the same document at once on Onshape and other things like that. So for collaboration, Onshape is also better in my opinion. Hope that answers your question.
Yep, it does. Thank you.
All right. So
that's it for today. Yeah, as we said, you can message us if you have more questions later on. I think we can end our meeting right here. Thank you, everyone.